Well. Good morning, good afternoon, and good evening, everyone. Welcome to the first episode of this YouTube channel. Here with us, we are going to discuss a brief layout of this particular topic. We are the GEMS, the Artificial Intelligence GEMS group, and the members present in these groups are Madam Aisha, then there's me of well, we have Madam Marie, and then Jack. Aisha. Now, in our group, the work is just straightforward. The first question was all about local search algorithms, and under local search algorithms, we've been tasked to lay out the foundations of all those highlighted algorithms. One is hill climbing. What do you know about hill climbing algorithm? It's just a local search algorithm which continuously moves in the direction of increasing elevation stroke value to find the highest point or the best solution to the problem. This one continuously helps in optimizing the mathematical problems. One of the widely discussed example of hill climbing algorithm is like, let's say, as a traveling salesman moves from one point in which he needs to optimize the distance whereby he's going to sell his particular product. That is the brief about hill climbing. Then there's what we call simulated annealing or simulated annealing. I don't know how any most of you people call it, but that's how I managed to. Hmm? Though I'm not a British person. This one is inspired by the annealing process in metallurgy, where a material is heated and then slowly cooled. It allows the algorithm to occasionally accept solutions that are worse than the current solution, which can help it avoid getting stuck in local optima. They are straightforward. Next, we have the genetic algorithm. We all understand, or we've all encountered the term genetics. Now, in an artificial intelligence way, these are just a class of optimization inspired by the principle of natural selection. They're useful for solving complex optimization problems where the search space is large and intricate. Mm. Wow. Next slide. It's all about the explanation of artificial intelligence, and whereby we have the explainable and the responsible AI. Now, with explainable AI, it has the ability. This is the ability of AI system to provide clear and understandable explanations for their actions and decisions. Its central goal is to make the behavior of this system understandable to humans by elucidating the underlying mechanisms of their decision making. Elucidating is like uh, laying it to us in a format that we are able to interpret it so quickly. Now, the same applies to responsible AI. It's an approach by which AI systems are designed and implemented in ways that recognize and are sensitive to human interaction context without infringing on core values and human rights. A case in point, and I can give you, is your own cell phones, the smartphones, the iPhones, the Samsungs, the Technos you use. Those are, by the way, AIs, because we normally interact with them. If I'm trying to communicate from my point X to point W to, say, Mr. Livingstone, who is in a certain point, uh, this device will operate in the context whereby I'm interacting with Sir, but without infringing on his core value. That is what we understand by the term responsible AI. Now, next on the list is these are self-explanatory. How do we incorporate a responsible AI? You need to follow some parameters. You need to consider there's what we call fairness, there's transparency, there's responsibility, and you need to account for every kind of steps. Let's say for accountability, establish a proper mechanism for oversight and accountability. Oversight is like you're scanning, you're trying to supervise the algorithm. Is it ethical and responsible enough? That is the major goal. Um, Still under the parameters, there's autonomy, there's adaptability, interpretability, explainability. All these are just self-explanatory points. You can take them: autonomy, maintain control and freedom of choice while interacting with AI system, and emphasizing due respect for human decision making. Need the device itself, the AI which is developed, it should not go beyond someone's, how do I term it, someone's life. Now, next, that was under question 2. It was all about the adversarial search. The AS is a type of a search algorithm used in game theory where two opposing players take turns making moves. The goal is to find the optimal strategy for each player. This type of search is often used in games like chess, checkers, and tic-tac-toe. When we mention about tic-tac-toe, this reminds us on the module which we covered some 2 months back. It was taught by Mr. Twafik. It was so enticing. Yeah. Now, under AS, we need to consider some scenarios like negotiation. You need to negotiate with your partner. For example, a company negotiating a contract with a supplier might use such kind of model to predict that the supplier counter offers and develop its own optimal strategy. Uh, Today, you may be the project director and you're being tasked to construct, let's say, a 1,000 square meters of a warehouse. So for you, you will develop all your BOQs and share it with the potential vendors. The potential vendors can use such kind of AS to determine whether is it Jimmy is going to procure all these, source all of these items to execute this project from us. If not, they will go back to the drawing board and at least get a model where they can be able to win. Uh, Now, the B part of the question was all about the minimax algorithm. What does minimax algorithm, from the word mini and maximum, comes from? This is just a recursive or a backtracking algorithm which is used in decision making and game theory. It is used in two-player zero-sum games where one player gains and the other loses. How does it work? Briefly, that's how it works. And what are the examples of such algorithm? I've just mentioned some few seconds ago in tic-tac-toe. The minimax algorithm would assign a utility value, let's say 1, to a winning position, and then -1 or any figure, let's say 0, to a losing position, and to 0 to draw position. It would then work backward from these terminal nodes to determine the best move for the current player. Wow. Next is the expect mini-max algorithm. Is a variation of mini-max algorithm used in artificial intelligence systems that play two-player zero-sum games with chance elements such as a poker or a backgammon. Kinda hard to that word. How does it work? It to the first one. It allows the probability of different outcomes. That's a major one. And the example is in poker. Then the alpha beta pruning, a technique used to optimize the minimax algorithm by reducing the number of nodes that need to be explored. How does it work? It maintains two values of each node, the alpha and the beta, alpha representing the best value and the beta representing the best value found so far for minimizing the player. The example is there, self-explanatory. That's it. Quite interesting. There are different types of attacks. The targeted ones, the non-targeted ones, the white box attacks, the black box attack. Okay. Um, yes. Basically, this is this is what we are supposed to do in simple. Thank you.